Let's start with this problem. Suppose we need to paint two walls. One is 3 meters tall and 3 meters wide, while the other is 2 meters tall and 4 meters wide. For which of these two walls we need more paint? The bigger the wall, the more paint we need, so we need to find which of these two walls is bigger. Note, however, that the first wall is taller, while the second is wider. To find which one is bigger, we'll introduce area, and for now we won't use formulas. If we have some figure phi in a plane, then generally speaking, the area of that figure is a measure of how big that figure is. So area is a measure of figures in a plane, but we want it to have some properties. First, we don't want it to be negative. Second, if some figure phi prime looks the same as figure phi, that is, phi and phi prime are congruent, then we want their areas to be equal. Now, if we have two figures, phi and phi prime, and they don't have to be congruent, what is the area of their union? In this case, the area of their union is equal to the area of figure phi plus the area of the figure phi prime. However, if phi and phi prime intersect, we counted twice the area of their intersection, so we need to subtract it. The variation of the third property is something that we'll often use, and that is if a figure is divided into n parts, then the area of that figure is equal to the sum of areas of its parts. Are these three properties enough to define what is area? Almost. Note that if we say that area of every figure is equal to 0, then it would have these three properties. To avoid this, we need to choose some figure with respect to which we'll measure other figures. It is agreed that that figure is a square whose sides are of unit length, and for it we say that has unit area. If this length is 1 centimeter, then the area is 1 square centimeter. If this is 1 meter, then the area is 1 square meter. And if this is 1 kilometer, then the area is 1 square kilometer. Just as centimeter, meter, and kilometer are units of length, square centimeter, square meter, and square kilometer are units of area. However, in mathematics we are not constrained by physical quantities, and we can say that if sides of a square have length 1, then its area is also equal to 1. And in this case, area is dimensionless. Let's now return to the problem of painting the walls. If we divide this square and this rectangle into squares whose sides are 1 meter, then the square is divided into 9 and the rectangle into 8 smaller squares, and each of these smaller squares has area of 1 square meter, so the area of this wall is 9 square meters. And the area of this wall is 8 square meters. So we need more paint for the first wall. Also, note that the circumferences of the square and the rectangle are equal, while the area of the square is larger. With that in mind, I leave you with this question. Is always the area of a square greater than the area of a rectangle if their circumferences are equal? That is all for this video. If you liked it, click the like button, it helps with the YouTube algorithm. And I'll see you next time.